Hi, welcome to a new video. Today we want to look at the Bernoulli distribution. I want to give an introduction and then we will look at how this is implemented in TensorFlow Probability. So it's about the Bernoulli distribution. This is probably one of the simplest distributions, probability mass function, that you will encounter. And it is associated with discrete events that can only take two values. And let us start with an example. And if you look at the weather in really simple terms, then you might say, okay, well, the weather is bad or the weather is good. And if this is some sort of a random event, then those kind of bad and goods are possible instantiations of the weather. So the weather, let's call it shorthand W, can take values either in bad and good. And if we say that bad, for instance, means 0 and good means 1, then we have our Bernoulli distribution. So we say the weather is distributed according to a Bernoulli, and this Bernoulli has a certain parameter that we call theta. And theta, that's the probability of good weather. And let's say, for instance, theta is 0.8, so you're lucky living in a region where it's mostly good weather. Okay, how can we encode this? So whenever we have a good weather, we are getting this with 80% probability, and a bad weather with 20% probability, because it has to add up to 1, obviously. And how can we encode this? So we write P of W for the probability mass function of W, and so we say it is 80% if the weather is good. So theta, and let's raise this to the power of W. So in this case, if W is 1, then theta to the power of 1 is theta, so it's theta. And if we multiply this with 1 minus theta, which is the probability of bad weather, so 20%, and you raise this to the power of 1 minus W, then we see that this is exactly true if we have a 0 if we have a bad weather. How does a dataset look like? So assume we are observing the weather for multiple days and we are getting some sort of a dataset. So let's call this a D, use the curly braces, and for instance, we observe good weather, bad weather, bad weather, good weather, good weather, good weather, and so on. And this would also be encoded similarly as we said 1, 0, 0, 1, 1, 1, and so on. And we can then determine the probability of the dataset, or in other terms, its likelihood. And the likelihood or the probability of the dataset is defined as the product from 0 to n minus 1, because we have n observations, and it's the probability of the weather being the ith observation of the weather. And if we then plug this in, we get the product from 0 to n minus 1 over theta to the power of the ith weather sample times 1 minus theta to the power of the 1 minus the ith weather sample. Let's plug this in for the first two components, and we get theta raised to the power of 1 times 1 minus theta raised to the power of 1 minus 1 times theta to the power of 0 times 1 minus theta to the power of 1 minus 0, and so on and so forth. And we see theta to the power of 1 is theta, and anything to the power of 0, what we will get here, is 1, so this will add up to theta. And here, theta to the power of 0 is 0, obviously, and here this will be 1, so we multiply this with 1 minus theta, and so on and so forth. Okay, I'm now in a terminal, and I open up an interactive Python session. Then I will first import a package in order to suppress TensorFlow warnings. Then we can import TensorFlow itself. And we can import TensorFlow Probability. And once we have it, we can start instantiating our weather model, which was tfp.distributions Bernoulli. And then we set the probability to 0.8. It is really important that you do named arguments here. And we can also give this another name, the weather. Look at it again, and we see distributions Bernoulli, the weather distribution, perfect. Then we can sample it. So as if we would observe the weather, and we see, well, it's bad weather. Then we can do it again. Oh, good weather, great. And we can even sample it multiple times. Then we get bad, good, bad, good, and so on. And once again, another sequence. We can create a data set by sampling it 10 times. Look at the data set, exactly the same. And we can infer or defer the likelihood or the probability of the data set using weather.probability of the data set. And then we see, oh, we're not getting the likelihood, but we are getting the probability of each event. And obviously the probability of the weather being 1 is the theta value, so 0.8. So in order to get the likelihood, we have to reduce this, and we have to reduce it to a product. So it's tf.reduce product of the weather.probability of the dataset. And here we go, and that's the likelihood of this particular observation.